Lesson 2.1 is a Algebra 1 review, and just reviewing relations and functions, graphs, points on graphs, different things like that. So I'm going to speed through this pretty quickly. There are a lot of slides, but it's all information that you've heard before. So the first thing is the Cartesian plane. Sometimes we just call it a graph, but the proper name is the Cartesian plane, and that is the intersection of a horizontal number line. So here's your horizontal number line, which is your x-axis, and the y-axis is a vertical number line. Where they intersect is called the origin, and the axes split the plane into four parts. Here's your first quadrant, and then you go counterclockwise, so second, third, and fourth. So those are called quadrants. There's all kinds of points on this graph, so we can locate different points here. So this point right here, for example, we look at the horizontal value first. So we come over here, it's 1, 2, 3, 4, 5, 6. Our horizontal value is 6, and our vertical value is 2. So that point would be the point 6, 2. And remember, these are number lines, so these are your positive x values over here. These are your negatives. And then for the y-axis, your positives are up here, and then your negative y values are down here. So it says graph the following points. Points are usually named with capital letters. So point A is at negative 2, 4. Remember, our x value or our horizontal comes first, so we go to negative 2. And then we go up 4. 1, 2, 3, 4. So here's point A. Point B is at 6, negative 5. So our x value is 6. The y value is negative 5. So we go 6. 1, 2, 3, 4, 5, 6, and negative 5. 1, 2, 3, 4, and 5. So that's point B. And then 0 is 7. So our x value is 0, so we don't move left or right at all, and we go up 7. So no horizontal change, up 7. 1, 2, 3, 4, 5, 6, 7. Here's point C. So A is in the second quadrant, B is in the fourth quadrant, and C is actually on the y-axis. It's not in a quadrant. So definitions. So the first one here, relation. A relation is just any set of ordered pairs. We usually deal with numbers. So a relation we put in brackets or braces, some people call them. So our relations will be in here, and it's a set of ordered pairs. Ordered pairs means there's two things. So here's your set of ordered pairs. This has 3 ordered pairs in it. This is what we'll normally deal with as numbers, but here's another relation. It's just cat, kitten, dog, puppy, and bear and cub. It's a set of ordered pairs. Relations can have a finite or countable amount of ordered pairs, maybe 10 or 20 or 3, or it could have an infinite amount. We, in Algebra 2, usually deal with ones that can be written as equations. This next part just tells us that x is called our independent variable and y is the dependent variable. The reason is, as you look at an equation here, y depends on what x is. If I put 3 in for x, y depends on that. Y would be 9. So y is the dependent, x is independent. Our domain and range, the domain is the set of all the x values, and the range is the set of all the y values. So here's an example. It says state the domain and range of this set. Well, the domain is the set of x values. And normally what we do is we put them in order. So our lowest one is negative 3. So it's still a set. So we got negative 3, negative 2, 2, and 12, because we want to put them in order. Our range, now we're going to look at the y values. So 4, 7, 5, and 4. Well, notice we see 4 twice. We only have to write it once. It's the same number. So we have 4, 5, and 7. That's our range. So this is a finite set. It only has 4 ordered pairs to it. Listing domain and range of an infinite set is going to be a little bit different. List the ordered ways to represent relations. Well, you can just list the ordered pairs, and this should have braces around it. So we have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. There's also called, well, let's go down this way, an equation. So you have the equation, y equals x squared, and sometimes we'll have another thing here besides y, which we'll talk about soon, for the domain -2, -1, 0, 1, and 2. So these mean the exact same thing, because if we put -2 in for x, -2 squared is 4, we would get this point. Put -1 in. -1 squared is 1, so when we put -1 in, we get 1. You put 0 in, 0 squared is 0, and continuing, so that you can write it as a list of ordered pairs, an equation, a table, which is very much like a list of ordered pairs, just in a different form, a mapping. So the mapping, you take your domain values and write them. You write your range values, and then you connect where they go to. So looking up at our list of ordered pairs, -2 is paired with 4, so -2 has an arrow to 4. -1 is paired with 1, so you go from -1 to 1, 0, 0, 1, 1, and 2, 4. And then we could graph all of these points, and you get these 5 values here. And so there's different ways to represent relations. Represent relation E, shown below, not to the right, using a set of ordered pairs. Well, set of ordered pairs we want to put in brackets. So we have -1, -3, because this is our domain and this is the range. So -1, -3, 1, 1, and 3, 5. A table, we just list our x's and our y's. So we have -1 goes with -3, 1 with 1, and 3 with 5. And then we can graph. So to graph, we want to graph these points, so we'll put our value, our number lines here. So our first one, -1, -3. So -1, -3 is here. 1, 1, so right one, up one, and 3, 5, 1, 2, 3. It's about right there. And so there are the lists, the graph. There's the graph. The one we don't have here is an equation. All right, so we talked about a relation. It's just a set of ordered pairs. A function is actually a special type of relation. So the definition of a function is it is a relation, so it's definitely a set of ordered pairs. So when we talk about a function, it's still a set of ordered pairs. It's a special type of relation in which every domain element, the first coordinate or the x value, is paired with one and only one range element or second coordinate, which we're talking about, the y value. So this one's a function because 2 is only paired with 8. You don't see 2 paired with anything else. 3 is paired with 7. You don't see 3 paired with anything else. And -1 is paired with 5, and you don't see -1 paired with anything else. This is not a function. -1 is paired with 4, and you don't see it paired with anything else, but 2 is paired with 7, and then 2 is also paired with 9. So you can't have the same x value go to different y values. So here's another example. Given an ordered pair that you can add to this relation that would make it not a function. So as of right now, with just these 4 points, 7, -4, 6, 1, 4, -3, and 10, 0, it would be a function. We want to add something that would make it not be a function. Now there are an infinite number of points we could put here, but what we want to think about here, I'm just going to make this simple. 7's paired with -4, and 7, in order to be a function, couldn't be paired with anything else, so we'll just put 7, 0. So now this is not a function because 7's paired with -4 and 7 is paired with 0. Some other options, obviously not all of the options, is we could have done 7 with 3, or we could have done 6, and 6 is 1. We could put 6 with 0, or 4 with anything besides -3, maybe 21. So those are some other options there. So that was the definition of a function. If you have a graph, there's other ways, or another way to determine it. The vertical line test. If 2 or more points of a graph lie on a single vertical line, then the relation is not a function. So this is testing to see if it's not a function. So state whether each relation is a function. Looking at this one, we have 3 points. -2 goes with 5. -1 goes with 7, and 0 goes with 5. This is okay. This is a function. -2 is not paired with anything else besides 5. -1 only goes to 7, and 0 only goes to 5. So even though there's 5's here, it's okay. You can repeat the y value, you just can't repeat the x value. Same idea here. -12 only goes to 1, -3 to 2, and 6 to 1. -3 and 6, sorry, -12 and 6 both go to 1. That's okay. They can go to the two different x values can go to the same y value. Here we have a vertical. We can check the vertical line test. So what we want to do here is we can draw a vertical line, and we can use that vertical line and see, does it ever pass through more than one point? Well, it only ever passes through one point as we slide it along here. It never passed through more than one point on this graph, so this one is a function. Over here to this one, we're sliding across here, and right here, it passes through more than one point. It passes through a point here and here, so therefore, since it can pass through more than one point, it's not a function. All right, graph the relation and explain using the graph whether it is a function or not. So we got -2, 4. This looks like the graph that or the relation we worked with before. -1, 1, 0, 0, 1, 1, and 2, 4. So what we'll do here is we'll take a vertical line. So it says explain using the graph if it's a function. So we're going to look at this vertical line, and does this pass the vertical line test? So do I ever pass through more than one of these points? Well, there I'm passing through 1, 1, 1, 1, and just 1. So it is a function because there's no vertical line that passes through 2 or more points. So it is a function. It passes the vertical line test. Some people actually just do VLT, vertical line test. Here's a little thing, a little machine. We can think of a function as a machine. You put something into the function. This machine does something to it. So you put something into the machine, it performs a function, and then it gives you an output. So for example, we could take the number 8. That goes into the machine. Well, when you put something in, it multiplies it by 2, which would be 16, and then subtracts 7, which would be 9. So you put 8 in, you get 9 out. You can put other numbers in there. You could put a -3 in there. Put -3 in. 2 times -3 is -6. Minus 7 is -13. So you can think of a function as a machine. There's function notation. We have this f of x. This just is one kind of one variable together. It's the same as y. This is helpful to write it in this form if we have a bunch of functions and we want to have an f of x. We could have g of x or whatever, h of x. X is still the independent variable. F of x is the dependent variable. So here you see f of x equals 2x minus 7 is really the same as y equals 2x minus 7. So we'll be using both notations for this. This example says evaluate f of x equals 9x minus 4 if x equals negative 3, 2, and 4. So here's how we can write this. This is one advantage. We can write f of, and we're going to put negative 3 in for x. Now this does not mean f times negative 3. I know it looks like that, but it doesn't mean that when it's written in function notation. So when we put negative 3 in for x here, we put negative 3 in for all x's that we see. So we put negative 3 in for x. So f of negative 3 is negative 27 minus 4, which is negative 31. We can do the same thing with 2. We can do f of 2, which means we put 2 in where we see x. And we can simplify this. So f of 2 equals 9 times 2 is 18 minus 4 is 14. And then the last one here we can put in 4. So we can do f of 4, which means we put 4 in for x. So 9 times 4 minus 4. So f of 4 is equal to 9 times 4 is 36 minus 4 is 32. So we get f of negative 3 is negative 31, f of 2 is 14, and f of 4 is 32. The last thing says graph. This thing. So let's look at this. It's in brackets, so it's a relation. And then it wants us to graph all x comma g of x. So these are a bunch of ordered pairs. So we want to graph ordered pairs. And our ordered pairs, it tells us that g of x, so the y value here, will equal negative 1/2 the x value. And so if we're given an equation, what we can do is we can pick a few numbers to plug in for x to see what g of x will equal. And we'll do that with a table. And then it actually asks us only to graph from when between x is negative 2 and 4. So here's x equals negative 2. We don't want to graph anything. We only want to graph from negative 2 up to 4, thinking of the x value. So here we go. I have this equation. So I'm going to have x and I'm going to have g of x. And so what I'll do is I'll just pick a few numbers here between negative 2 and 4. So let's do negative 2. We could do all the integers. I'm going to skip a little bit. So negative 2, 0, 2, and 4. And what I do with these is I plug them into this. So if I put negative 2 in for x, I have negative 1/2 times negative 2, which is 1. And so I have the ordered pair. Negative 2, x was negative 2, g of x is 1. So I have negative 2, 1. Putting in 0, negative 1/2 times 0 gives me 0. So I have the point 0, 0. It's not right on the that's the origin. Putting 2 in, negative 1/2 times 2. Negative 1/2 times 2 is negative 1. So we have the point 2, negative 1. Looks like we're just going to have, these are all right on a line here. So let's try 4 and see what we have there. Negative 2 times 4. Half of 4 is 2, but it's negative, so negative 2. We get 4, negative 2. Now here's something that we have to think through here. We want all x values between -2 and 4. So we want all these x values to be represented. We chose a few numbers to find ordered pairs. So we have 4 ordered pairs, but it's not just asking for 4 points, it's asking for all points between here. So if it has some values here that you want to do, then you actually connect these with a line. Wasn't very good. Which means all points along this line will be part of this relation or function, which it is a function. So all these points. So our answer is this segment right here. And that is our review of relations and functions.